All right, Milton. Let me just take a look at and your current model. I think this is the latest model. You added the map foundation, right? So let's go through that where you are. All right, I think you drew the strip, this, and I'm gonna turn up the strip. I'm gonna take a look at it. You assign 9 feet mat C6. So I'm just checking your mat 9 feet, and you see 6 means you need to choose 6,000 psi, right? And instead of slab there is a mat element, so okay, you adjust it. So this one had a 6, and you assign the spring constant as well. We'll take a look at it later. All right, so I think your structure is a huge. You have a 50 by 50, which is not common, but we'll just keep it as it is. All right, so I'm gonna save it. Okay, so the first thing I need to know, what you need to, I'm gonna just move around and see where you are. The load, you assign all the loads. Service load 98, 8 exposure B. Okay, instead of all, I think it should be 1. So this one should be 0. So win is win X. Okay, and parallel to X direction should be 0 degrees. SY wind load. Okay, instead of 12, case 1, but this one should be 90 degrees. And 98 mile per hour is our service wind, basic wind speed. All right, so wind load, this one is 115 is ultimate wind load exposure B. These cases we're going to consider all 12 cases right there, right? Okay, what else? No, actually wind L, wind, you have a 2 wind. Let me see. Okay, you already have it here, so I don't know what is this wind L. You can delete it. So you have already service wind again 98 versus ultimate wind is 115. So I'm just checking here. And okay, the first thing I want you to do is we need to just develop further the wall, because we cannot can I leave like this. The first thing, I'm gonna just use this as a grid, and we can draw Milton wall 1. We need to tie this wall, right? So I'm gonna draw the wall below. Now we need to just mesh it. Okay, so this wall and this wall, we're gonna mesh it by 1 by 3. Divide the wall. So 3 and 1. No, undo. Instead might be the 1 by 3. What? Divide selected shell. Wait a minute. Okay, I'm gonna select again, and what's going on here? Wide. Okay. Again, go back again. I'm gonna select this wall. Oh, this wall. Oh no, this wall. Yeah, even this is entire wall. Okay. So first of all, 1, 2, 3, 4, 5. Okay, just one piece, right? So we're gonna break it into the 4 first, right? You see that? Now 1, 2, 3, 4, right? And then we're gonna divide another 3. Okay, so based upon this, So what? Which floor we choose? Wait a minute. You have a beam, so we're gonna delete this beam. Okay, turn off the wall. I'm gonna delete this. Going turn on that. Okay, right. So this wall is divided by 3. This shrink options. 7 is maybe too much shrink. All right, so this is the wall profile we're gonna use. So what we're gonna do, we're gonna delete in the middle, so that assume this is elevator hole, right? And then going back to plan, we're gonna draw that the link beam to tie this. So let me turn on this wall section ID. I'm sure you're using this 1 foot. I'll just use something like this. And again, you need to come up with a sign convention, name convention, right? This is 1 foot. So obviously you need more. So 24 W 2 feet for now, and C 6. All right, and if you want, you can make another 18 W C6, but I don't think we need to create more the concrete strength. Okay, so first I think so we need to also create the link beam, concrete beam, right? Rectangular beam. Same thing, link beam. Typically we match the wall thickness, so 12 by maybe 30 C6, which is I'm gonna try 2. Depth is 30 inches, right? 2 by 2. Okay, so for now I'm gonna use this as a link beam, so we need to define more. So you're gonna draw the link beam here. Okay, so I draw this, but I think so we need to somehow modify all the wall above. So what I'm gonna do, I'm gonna put XY plane and show all, and I'm gonna select only this entire, right? See, so I'm gonna delete and all this, and then I'm gonna copy this one again, story 2 42 story 2. So when you see it, oh, there is also boundary condition was assigned, copied. So I just put it back to 0, totally free. So this is the your building configuration. I'm gonna save it. So what you're gonna do at this point, why don't we just run the analysis, see what your wind deflection with the 12 inch and C6 concrete. So, but do we have a diaphragm? Okay, let me put it in 3D. Okay, seems like, let's run that model. Okay, the model is okay. Let's check. All right, so with that, we'll just check the overall displacement of 40s. The first thing is deformation again, due to the wind X. So at the top floor, wind is blowing X direction, right? This overall behavior, Y directions. Okay, Y, right? You need to check every connectivities just in case. Okay, 3D. So you'll see this. Okay. So now what you can see, your display story response spectrum. What you can see, you could just check wind X direction, right? The maximum story drift. You see that? 0.197 feet. Let's change to the inches. So 3.25 inches here, right? Oh no, this is that lot. Because your building is huge, the core wall is huge. So let's see, extraction, we have a 2.3 inches, right? Then the wind Y direction, because the wick axis is 14.9 inches, right? So I just mentioned that you could click, then you can collect all the data and post it in Excel. Right, and summarize in chart. So this is Y direction, wind Y, service wind Y deformation, right? And you could do that in X direction as well, right? You could grab this and summarize it. And also you may be want to interest, because I show you the overall poster total wind. Where did it go? Where is the other wind? Hold on a second. So we have wind, right? What are the load cases? Wind. Oh, we don't have a wind here. That's why something is missing. Okay, is it this one meant to be a wind? No, dead load. I think something is missing. Okay, so we cannot check the ultimate wind. I'm gonna turn up and go back and fix it. So wind cases, this is dead load. Should include the dead load, right? Oh, this one is wind. Okay, so this one you should be wind. Somehow you typed wrong. So this is ultimate wind load, right? And this is dead load. Should be okay, include that. So this is that. So it should be considered modal analysis. We'll delete it at this point. Spoon post dead load should include spoon post dead load. Okay, and construction live load, and this is each wind load. All right. So I think this model is something. Let me just run one more time. Let me show you the total wind story shear and overturning moment. You can summarize it in Excel as well, similar way. And so this is, I think, good for now for your lateral system study. But I think what you need is that you need to define the wall thickness and associate with the concrete strength. So you can just maybe break and categorize maybe in 3 different zones. At this point is 12 inches, C6 is go all the way up, which we haven't done this yet. Okay. So here display story. So if you choose a wind, and here instead of deflection story shear, right? This is storage. Storage shear, wind, storage shear in X direction. This is cumulative shear forces. So here you see we need to change to Kips. Yes, because when you need to change, I need to restart, refresh. Okay, wind, storage shear in X direction. Here is 30,000 Kips, right? With Y and the wind Y direction, ultimate wind, I'm sure it's going to be double, more than double, because the wind belaying is much wider. So 8,000 Kips. This is again the ultimate wind load based upon basic wind speed 115. All right, so this is just a checking procedure. What you need to do is you need to define, create this wall section property and concrete strengths, various concrete strengths, and then in group each group you can just assign the wall and link beam similar way and kind of do some iteration. I think your building, your core wall is much deeper, 50 feet, so 40-story building, 50 feet. Yeah, obviously you don't have any much slenderness effect ratio. So based upon current analysis, the wall thickness 12 inches seems okay, but that's not realistic size of the core wall. Okay, I'm gonna stop here.